Hi class, here is the second lesson for Unit 2. It's called Multiple Representations of Linear Functions. First of all, I just want to mention a linear function. The main two things for a linear function are the slope, which we've been practicing a lot. So let me go ahead and put one of our favorite forms that we use for linears, which is y equals mx plus b. Okay, and I want your eyes to fall on m, which we know for it to be the slope. It tells you how the shape of the line, basically, if it's positive, negative, 0, and the steepness as well. And then the other number I want you to see, or the variable in this case, is b, which is the y-intercept, where the line crosses the y-axis. We're going to pay close attention to these two numbers, okay? Just remember that the slope is attached to our variable x. Okay, so here we're going to look at different ways that we represent linear functions. The first way is an equation. How do you know it's an equation? Well, you see the equal sign, and then you see y equals, and then you have 2x plus 3. This is the equation. Or we have function notation. We'll do more of function notation in the future lessons. But for now, go ahead and focus on this one right here, which is the equation y equals mx plus b. In this case, we can see that the slope is 2. So this has a slope of 2. Okay. And then we know that the y-intercept is at 3. Okay. And you know what that would look like, right? Let me go ahead and jump down to the graph, because I want you to see how this equation right here, we can do it on the graph here. So when we're graphing it, the starting point will be at 3. So y-intercept, you can think of it as the initial value. Okay, let me go ahead and write that here. I'm going to write it in parentheses. Initial value. Initial value. Okay, because you're going to see this term a lot, initial value. It just means the starting point where your the data kind of starts from. So it looks like this, it starts from here, the y-intercept on the y-axis right here. It starts at 3, positive 3, 1, 2, 3. And then from here, we're going to go ahead and count the slope. So the slope is 2. It's not just 2, actually. It's 2 over 1, the rise over run. Okay? So it's going to be rise is 2, 1, 2, run is 1. We can continue with that and make it a step, 2 over 1, and then so on. So this is the line right here of, or I should say the graph of this equation. Let me just do that. I can actually go ahead and extend it out a little bit more right here. I'll just go right there. I'm just making the same distance, right? And then so on. Okay. So you have an equation, y equals, our favorite type of equation is y equals mx plus b. And then this is the graph right here. Okay. This is the y-intercept of 3. So we'll call this the y-intercept. Let me visually show you what that is right here. And then you have your slope of 2 over 1, which is this one right here. Okay. All right, so you have your equation graph. Now let's look at a table of values or ordered pairs. So let's look at the table of values. For table of values, we start with x. This is the independent variable, meaning that you could pretty much put any numbers here, and depending on what the independent variable is, we'll get our y values. So we're going to do, let's do -2, which is kind of our standard. Put in a different color, -2. Let's go ahead and do another value of -1. We'll do 0, 1, and 2. And then what happens here is we take our values of x and we plug it into our equation, and then we find our y values. If you don't have an equation, if you just have a graph, we can use that as well. I'll show you how to do both. All right, so for our equation, I'll do one by hand, and then the rest of them, I'm just going to go ahead and use Desmos. So to find the y value, you're going to go ahead and take your equation 2, and then we're going to plug in our x value, which is 2 as well. So I kind of build a skeleton. You can think of it as a skeleton where we have we're trying to look for our y values on this side. And to get all of our y values, we can go ahead and keep changing the x to whatever we have for x. So in this case, our x is -2. So that would end up being -2 times -2 is -4. -4 plus +3 is -1. Okay, let me go ahead and bring up Desmos and show you. So you have your equation, which is at 2. And then when we're plugging in numbers, we like to use parentheses. And the x that I'm plugging is -2, because that's what I have there, +3. And the value is -1. So we can do the same for the rest of them. I'm plugging in -1 here. 0, +3, 2, 1, +3, and then 2 times 2, and then +3. Oops, this was supposed to be 3. Okay, so there are all of my y values. Okay, so in this one, we got, when I plugged in -1, my y value was 1, and then so on. When I plugged in 0, my y value was 3. When I plugged in 1, my y value was 5. And then when I plugged in 2, my y value is 7. Okay, so to put it all together nicely, let me write out my ordered pairs here. So my ordered pairs are, the first value is always your x value, and then the second value is always your y value. So when my x is -2, my y value is -1. Okay? When my x value is -2, my y value is -1. When my x value is -1, my y value is +1, and then so on. Okay? -1 goes to 1, then 0 goes to 3, 1 goes to 5, and then 2 goes to 7. Okay? And let me go ahead and show these same points on this line right here. So -2, so x is -2, y is -1. See, that works. -1 goes to +1, everything lines up. 0 goes to 3. This one is a special point. Let me point that out to you in just a second. 1 goes to 5, 1, 2, 3, 4, 5. It's right here. And then 2 goes to 7. Okay, let me go ahead and show you this point that I have here. Okay, we know that point to be y-intercept, right? We know that because it's crossing the y-axis. And then the coordinate for it, we can see that it's at 0, 3. Okay, I want you to notice that on the y-coordinate right here, when I look at just the table, I can tell that this is the y-intercept, because on the y-intercept, the x-coordinate is always 0. On any y-intercept, the x-coordinate is always 0. So you can easily figure out that 3 is the y-intercept because you see a 0 here. Okay, in this case, you can see 3 is the y-intercept because that's my y-intercept. That's the value for b that I have here. And then when you look at a graph, you can see this is the y-intercept because I see it crossing the y-axis. Okay, This ends up being pretty important in this unit, just recognizing how to find the y-intercept when you look at an equation. It's right there. When you see a table of values, you look for the value that has 0 as the x right there. That makes this the y value, y-intercept. And then on a graph, it's right here. Okay? All right. And then the last thing is, and you should know how to make this a verbal sentence and turn it into an equation. It says y is equal to the sum means addition, of 2 times the value of x and 3. 2 times the value of x and 3. So that's how we get our equation. Y equals 2 times the value of x plus 3, or the sum. All right, so more if we're looking at it on a practical sense, for helping a neighbor, teacher Tina charges a flat fee of $3. So whenever I see the word flat fee, that means that's my like initial value or my y-intercept. And then whenever I see the word per or per hour or per mile or things like that, that's how I know that this is the slope. So this is 2 times your slope plus my flat fee of 3, okay? And that's y equals. We'll spend more time on translation in the next unit, but for now, this is what it is, okay? All right, so let's go ahead and do some practice. It says here, suppose the water level of a river is 34 feet and it is rising at a rate, okay, rate is my slope, of 0.25 per hour. What is the equation of the water level L after h hours? Okay, so the water level L is equal to, remember that we have the slope. Slope is the same as your rate, so the rate looks like it's at 0.25, and you have your x attached to it, plus your y-intercept, which is your starting point of 34. Okay, what is the initial value? The starting point or the initial value? The initial value is at 34 because the river is already at 34. It starts off at 34 feet and then it keeps going up from there at 0.25 feet per hour. The rate of change is 0.25. Okay, all right, write an equation to represent y is equal to the difference. So the difference means subtraction. The difference of 1/2 of x and 7. Okay, so when I look at this, I can know that the initial value is going to be my y-intercept. You always make sure to carry the sign, so that's at -7. And then the rate is the coefficient of x right here. That's the slope, which is at 1/2. Okay. Let's go ahead and go through a few more examples here. It says a social media app charges $4 membership fee and then 50 cents for each post. Okay, so these are my two numbers. I just need to write a linear equation. I know that I have my slope times your x. My slope is 50 cents for each post. For each also just means like how it's changing. So it's changing at a rate of 50 cents. So I'll just put 0.5. You could put 0.50, but when we are using decimals, we just go ahead and drop that 0 right there. So y equals 0.5x plus the initial value is at 4. Okay, let's go ahead and graph this. When I'm graphing this, I always start with my y-intercept first, which is at 4, 1, 2, 3, 4 right here. And then this is my slope. My slope is going half, right? 0.5, which is just going not one full up, but it's only going half up and then 1 over. Half up and then 1 over. Half up and then 1 over. Okay? So I'm going to go down and then just do the opposite. go half down and then over just so I can get a line through here. And that's what it looks like. Okay. All right, write a table of values that represents the following graph. All right, so I have a table of value here. Sorry, no, I don't have a table of value. I have a graph here and I have to just write some values here. So I'll just go ahead and pick a few points. I'll pick this point. I always like to go from the left and then move to the right because these are where my negative numbers are for my x values. So I'll pick that point. I'll go ahead and pick that point. That's my y-intercept. There's one point. There's another point. Okay. So this point, the x value is at -2. And then my y value is at, what is that, 7? 1, 2, 3, 4, 5, 6, 7. Yep. My x value is at 0. My y value is at 5. 3 goes to 3. And then 6 goes to 1. Okay. All right. And then the last one, it says compare the 3 equations below. Which equation has the highest initial value? So initial value always just means the y-intercept. So let me go ahead and write out all of my information for each one. So my slope here is 9, this number. And then my y-intercept is at 5. So this is my slope and this is my initial value. For this one, my slope is at 1/2. And then my y-intercept is at 10. Here, my slope is at -2, and then my y-intercept is at 3. All right, so it says which equation has the highest initial value? Initial value of 5, 10, or 3? Well, this one is the highest initial value, so this equation, A equals 1/2 B plus 10, has the highest initial value. The next one says, which equation has the steepest rate of change? Okay. So this word, steepness, okay, the word steepness just means the shape of the line, okay? For example, let's look at it on a coordinate plane. So you have your x-axis right here and you have your y-axis, okay? And let's look at 2 graphs right here. Let's go ahead and look at this blue graph, okay? Compared it to this green graph right here, okay? So we're going to say that the blue graph is steeper than the green graph, because whichever one is going towards the y-axis more is the steeper one, okay? So basically it just goes higher. So the higher graph is the steeper one. But if I look at a graph that is on the negative side, meaning has a negative slope, okay, these just take a little bit of, practice, but you'll get it. Let's look at this red graph compared to this pink graph. Okay, the pink graph is going, well, can't even look at the pink graph. Let's look at a different color. Let's do this purple graph. The purple graph, let's say I draw it like this. You see how it's closer to the y-axis? So this is the y-axis. It's getting closer to it. So it's higher. If it's higher, so basically you can think of it, the steepness as the higher or highest. Is the higher rate of change, okay? Even if it's negative or positive. So I would say, in using that concept, I would say that 9 is the steepest. Let's go ahead and actually look at it on Desmos. So where's my Desmos? Okay. In Desmos, let me go ahead and graph these 3. Okay. The first one is at n equals 9p plus 5. Okay, there's the one in the red. The next one is a equals 1/2 b plus 10. Okay, getting something. And then the last one is, where's my other graph? Right here. M equals, just copying it just the way it is, negative 2d plus 3. All right, so it's kind of hard to tell, but n, the one in the red, is steeper, especially when you look at it, the negative one, the green one. It's like maybe that's a little steeper, but if you see that the red one is going a little bit more closer than the green one, okay? So I'm gonna say that the graph, which has the higher value for the slope, is steeper, okay? And then last equation, question, which equation demonstrates a decrease in the output as input increases? So basically, when you see the word decrease, it just means that it's going down. The decrease one would be the one with the negative slope, right? So that was an easier one. Okay. All right, you guys, thanks for watching.